Welcome to the virtual comprehensive soil erosion and sedimentation control plan review and design refresher course. This course is designed to cover 3 modules. The modules we will be covering are as follows. Module 1 is a review of SESC materials covered in the manual and a discussion of how and why these matter from a plan review and design perspective. Module 2 is a review of soil erosion and sedimentation control plan review and design, including how to avoid bad SESC plans and taking a look at common best management practices, or BMPs, and their installation and maintenance issues. Finally, Module 3 will cover inspections, permitting and enforcement, and in specific, why we do inspections and what can be done for permitting and enforcement. If you have questions and you are in a live event, we will have a discussion period between the modules where you can raise your hand and we'll unmute you and you can ask a question, or you can simply type a question in the comments area and we'll answer it there. Let's get started with Module 1, a review of SESC manual materials related to stormwater runoff and soil erosion and sedimentation control. Soil erosion and sedimentation controls are important because according to Erosion Control magazine, an estimated 80 million tons of sediment is discharged annually from construction sites. Drain maintenance is authorized at $5,000 per mile per year in Michigan, based on the Michigan Drain Code. An estimated dredging cost to the state of Michigan and local governments is $3.9 million per year, with an additional $9.3 million per year contributed from federal sources, according to the Michigan Sea Grant Program. Remember, it's better for the environment and most cost-effective to prevent discharges from happening than it is to fix one. Let's take a look at a couple of sites where Eagle took enforcement action for releases of sediment to waters of the state. The first is a well-known Southwest Michigan University. Let's see what happened there.
We're following a developing story surrounding a construction site at Western Michigan University. A State Department says that it found several deficiencies involving that project when sediment unlawfully entered Asylum Lake. These images just into our newsroom tonight show what happened last week when several inches of rain fell in the Kalamazoo area. That storm runoff went into Asylum Lake. The State Department of Environment, Great Lakes and Energy is blaming these murky waters on the ongoing construction at Business Technology and Research Park 2. The state agency says the construction team did not have proper erosion control measures. It also says WMU lacked the proper permit coverage for 2 months. The EGLE is now ordering Western to address these issues or be fined. The university says it's already doing so and plans on filing the necessary paperwork.
Wow, so that was some seriously sediment-laden water that was discharged into a wetland in a lake. These types of discharges destroy habitats and can carry excess nutrients and other pollutants to destroy water quality. Now let's take a look at some on-site Eagle video footage from a place in Eaton County where Eagle completed enforcement proceedings. So did you see any SESC measures installed? Do you think the measures were sufficient to control the erosion or sediment migration? The site could have done several things to control soil erosion, such as staging rather than exposing all that soil. The project could have been done in phases, stabilizing smaller areas when they were to final grade, or the site could have installed several different BMPs in succession to control the movement of sedimentation. Remember, it's always best to reduce or eliminate erosion rather than trying to control the sedimentation. When Eagle takes enforcement, it can be very costly. Let's see how that Eaton County site fared in enforcement. This is a news release regarding the Eaton County site. Eagle gave the site several chances to return to compliance, but ultimately took action to protect the natural resources in the area. The court ordered the company to pay a $243,500 fine, take actions to fully stabilize the site, and pay the court costs of $102,408 $345,948.75. That's a total of $345,908.75, not to mention what it will cost to fully stabilize the site. This graph shows the effects of turbidity on fish. Notice with only a few hours of exposure to low turbidity, fish show signs of stress. With prolonged exposure to turbidity at high rates, it causes death. The soil erosion processes of rainwater are defined as the following: sheet erosion, which removes a uniformed, thin layer of soil; rill erosion, which is when the rain concentrates and passes through the topsoil; and gully, which is a formation of deep incised channels. Rill and gully are the most obvious on a site. However, sheet erosion generally results in a greater loss of soil. Preventing soil erosion is important because prevention is often less expensive and less time consuming than performing restoration. Eagle recommends leaving as much vegetation in place as possible and staging the project to reduce the amount of exposed soil areas. Eagle acknowledges that many times the inspectors don't have a say in the staging, but you do have the responsibility to notify the site responsible party or permittee of the effectiveness of the SESC plan and measures. Vegetation is of utmost importance because roots stabilize and bind soil to prevent erosion. Vegetation also slows runoff, filters out sediment, and shields soil from raindrop impact. If vegetation is properly removed and staged, it can even reduce the cost of stabilizing since you could reuse it. Staging or phasing help prevent or reduce erosion by minimizing the area of disturbance. In layman's terms, only the active construction area has bare soil, and all other areas are still vegetated or stabilized. Though this is not widely used, it is highly recommended, especially in areas that are adjacent to wetlands, lakes, or streams. One of the best erosion control measures is to minimize the disturbance as much as possible. This is not always possible, but if you can phase or stage the project and minimize disturbance, it greatly reduces the erosion potential of a site. Buffer strips can assist in protecting sensitive areas. Well-established natural vegetation can protect wetlands and bodies of water from sediment releases by slowing stormwater flow and filtering out sediment. Reduce erosion, stormwater flows need to be slowed down. Surface roughening makes the slope bumpy and therefore slows the runoff as it proceeds downhill. Think of it like raindrops running over speed bumps. It can be easily accomplished by driving a dozer or other tracked vehicle perpendicular to the slope. Roughening also produces a soil surface more suitable for the growth of vegetation because it will hold the seed and retain moisture. Scarification is similar, but it is generally performed with a drag or a cultivator pulled across the slope, as in the bottom photo here. The process again forms a speed bump for the runoff to slow down as it makes its way down the slope. Know your seeding windows. Seed planting windows vary greatly across our state. It is important to know the seeding windows for your project area to give yourself the best possible opportunity to get that vegetation established. We have to this point discussed why to control soil erosion and sedimentation and some practices that can aid in the reduction of erosion. Now let's review some of the more common best management practices used for SESC. All of the following items should be reviewed during each site inspection. Products such as mulch blankets or turf reinforcement mats protect the soils and live seed from erosion and provide an environment to promote germination and growth of vegetation. Check dams are generally constructed of rock and are often installed in a series. A check dam's primary purpose is to slow the water velocity in areas of concentrated flow. They can also act as sedimentation controls if the water is slowed sufficiently to allow sediment to deposit on the upslope side of the dam. Diversions are used to route water around the worksite, which can reduce erosion during construction and promote work in the dry. Dust control should be implemented to reduce wind erosion across bare soils. Sites should consider leaving windbreaks of existing trees around the site, or in cases where dusty, dry conditions exist, should implement a wetting program to keep the soil moist. Silt fence is one of the most commonly used BMPs, and unfortunately, it is the most often misused and neglected. Silt fence should be installed in areas of sheet flow, never in concentrated flow. It should be installed along horizontal contours, trenched 6 inches in, and backfilled on either side. It is intended to remove sediment out of suspension by slowing the water as it passes through it. Turbidity curtains isolate the worksite. These, like all SESC measures, must be installed properly to function correctly. Cofferdams are often used on bridge replacements. They also isolate the worksite and protect the work area from water flow. A gravel access road can help reduce sediment tracked off-site during construction. Track out should also be managed with the implementation of a street sweeping program. Pay attention to the rock size. Too small of rock gets caught in the tires of the vehicles. And the rock will likely need new layers as the project progresses. Once you see that the rock is clogged with soil or mud on top, it's time for a new layer. The access road should be inspected as part of the site inspection, and it should be noted if the rock is becoming clogged with mud or soil. Inlet protection comes in a variety of products, depending on the location and configuration of the inlets. These products should be selected using the size, location, configuration, and manufacturer specification. Because storm drains often directly discharge to a stream or river, they should always be protected during construction. If you don't want your kids swimming in it, it shouldn't be leaving your site. All inlet protection devices need constant maintenance and should be checked during each inspection. Sedimentation basins are used to trap sand and large silt-sized particles during construction. Stormwater basins are designed to capture clean stormwater and release it after a period of time. These are not designed to handle large amounts of sediment from construction sites. There are two types of basins. The first is a detention basin. These are designed to hold the water for a period of time and then release it once it reaches a certain level. Think of getting in trouble in school and having to go to detention. You're eventually released. So these have an outlet where the water is eventually released. Then there are retention basins. This is where the water is fully retained within the basin and either evaporates or infiltrates the ground because there is no outlet. So think of retaining water. It won't leave your body unless you take it out of the ordinary steps to get rid of it. If converting a sedimentation basin to a stormwater basin, the accumulated sediment should be cleaned out after construction activities have ceased. Soil texture will be covered more in depth in Module 2. Soils are an important property to consider when you're approving and designing SESC plans. Sand is bigger in particle size and heavier, so it drops out of suspension faster and easier. In contrast, silts have the consistency of flour and will stay in suspension longer. Clays stick to each other and roll well in your hands when it's wet. They have the smallest particle size. And though difficult to erode, once in suspension, clays are not easily removed. In general, on this chart, as you go down and to the right, soils become more erodible. We must also pay attention to the soil groups when planning SESC measures. Soil group A has high infiltration and low runoff potential. These are sands and gravels. Group B has moderate infiltration and runoff. These include sandy loams, silty loams. Group C has low infiltration and increased runoff. These are clay loams. And finally, Group D, which has slow infiltration and high runoff, are clays. Part 91 is all about keeping your dirt on your site and out of the waters of the state and off adjacent properties. Part 31 is all about protecting the waters of the state from injurious materials. Part 31 also contains permit by rule. That's where stormwater permits are required from any construction activity that disturbs 1 or more acres of land and has a point source discharge to surface waters of the state. A point source is defined as a discharge that is released to waters of the state by a discernible, confined, and discrete conveyance, including any of the following from which wastewater is or may be discharged: a pipe, a ditch, a channel, a conduit. Point source also includes any runoff as a result of grading, regardless of it is sheet flow or concentrated flow. Under permit by rule, stormwater coverage from Eagle is considered automatic for the sites that are 1 to 5 acres, as long as the owner has Part 91 coverage. Sites 5 acres or more must apply for a notice of coverage from Eagle. Part 31 is enforced by Eagle. CEAs and APAs do not regulate or enforce Part 31, but the person responsible for the site must comply with the requirements. Permits must be issued in the landowner's name. A designated agent can apply for the landowner, but the permit must be issued to the landowner. The state requires that a permit issued for disturbances equal to or greater than 1 acre that are within 500 feet of a lake or stream. A lake is considered 1 acre of open surface water, and a stream has a definite bed and banks with visible evidence of continued occurrence of water. An agency may have an ordinance that is more restrictive than state requirement. So if the area is over 1 acre in size, you have to have a permit. If the site is 5 acres or more with a discharge to surface waters, it also must apply for a notice of coverage from Eagle via My Waters. So again, the permit must be issued to the landowner or easement holder. The permit requires that approved SESC plans be available on site and that the plans are maintained to reflect any necessary changes. After a Part 91 permit is issued to a landowner, they automatically have Eagle stormwater coverage for construction sites that disturb 1 to 5 acres under permit by rule. If a site exceeds 5 acres, the permittee must also file a notice of coverage via My Waters with Eagle. Permit by rule was developed under the authority of Part 31 for any construction activity that disturbs 1 or more acres and has a point source discharge to surface waters of the state. Part 91, inspections are required by the County Enforcing Agency, CEA, Municipal Enforcing Agency, MEA, or the approved public agency, APA, but also are required by the permittee under permit by rule. Inspections must be conducted by a certified stormwater operator, and permit by rule requires weekly inspections and inspections within 24 hours of a storm event. Part 91 is focused on keeping soil on the site, and inspections are required until the site is permanently stabilized. The primary goal of Part 31 is to protect and conserve the waters of the state. All construction sites must have all required permits before earth movement begins. The state has minimum required elements that must be on all SESC permit applications and all issued SESC permits. The state prescribed SESC application elements are as follows. Applicant with contact information, a detailed location for the earth change, the type, description, and size of the proposed earth change. So it's type, description, and size. It also has to have the name and distance to the nearest surface water and the project start and end dates. Also, an SESC plan needs to be submitted, and the developer of the plan with contact information should be included. Parties responsible for the earth change, including the name of the landowner and the name of the individual on-site responsible party for the earth change and their contact information. A performance deposit, if applicable, and a signature from the landowner or designated agent certifying that the work will be completed in accordance with Part 91, Soil Erosion and Sedimentation Control of the Natural Resources and Environmental Protection Act, 1994 PA 451 as amended, applicable local ordinances, and the documents accompanying the application. Permits also must contain prescribed elements, such as the permittee and their address, the permit number, the issue date, the expiration date, the on-site responsible person, including their name, company, and telephone number, a description of the permitted activity, the project location, permit conditions, the permitting agent, signature, and telephone number, general conditions of the permit, and any specific conditions prescribed by the CEA or MEA. There are 13 elements required to be included in all SESC plans. We will go over each of them in more detail in Module 2, but here's a quick refresher of the list. A map to scale of less than 200 feet to 1 inch, a legal description of the location, a site location sketch, the proximity to water, predominant land features, contour intervals or slope description, soil type, limits of earth change, any drainage or dewatering activities, the timing and sequence for the earth change, the description, location, and installation details for all temporary SESC measures, the description, location, and installation details for all permanent SESC measures, and a maintenance program for permanent SESC measures, including the party responsible for the maintenance. We will also go over this in more detail in Module 2, but in general, plans should be reviewed before issuing permits to ensure the plan complies with all Part 91 requirements, accurately depicts the on-site conditions, and the prescribed control measures will be adequate to effectively control erosion and off-site sedimentation. The person reviewing and approving the plans must have a valid plan review and design level certification, not inspector only, from Eagle. The various agencies' roles and responsibilities are as follows. First, County Enforcing Agency, CEA, which are required to implement Part 91 as written or to implement an ordinance or resolution which may be more restrictive. Next is the Municipal Enforcing Agency, or MEA, like a city, village, or township, which may elect to implement Part 91 through an ordinance which may be more restrictive than Part 91. The last agency is the Authorized Public Agency, or APA, which is a state or local government unit. These must have approved procedures through Eagle, and they do not issue permits, but they are required to have SESC plans that meet all requirements of Part 91 for non-routine construction projects. Eagle is responsible to provide program oversight and assistance to all the enforcing agencies and to review ordinances and procedures. Inspections are an important component for running a successful SESC program or for managing a successful project or site. All projects must be inspected by a trained individual. They should have a working knowledge of SESC techniques, plan requirements, permit conditions, and be able to recognize when measures are not effective. Permit by rule inspections are required weekly and within 24 hours of a rain event, resulting in a discharge from the site. We will go over this more in Module 3. Part 91 agency inspections should be performed often enough to ensure compliance with their SESC plan, SESC permit, or approved procedures in the case of APAs. We have now completed Module 1 portion of the virtual comprehensive SESC Plan Review and Design Refresher course. Thank you for your attention and your participation.